Hi and welcome back to a new video. About a year ago we launched our first GPU water block from Thermal Grizzly, which was for RTX 5090 Astral. And I can tell you the way of getting there, the road, was not easy. It was super difficult because we set our own expectation very high when it comes to features and surface quality and all these kind of things. We just wanted to have something absolutely top-notch and completely new. Something we just didn't want to just copy the market, right? And most of the things worked out, but not everything. But now we finally have our second water block again. It took much longer than we expected, but I think it worked out. This time, this water block is absolutely insane. It's for RTX 5080 Astral, and we will look at this today and put it onto this card. The Seasonic PX 2200 is currently one of the strongest PSUs available, and it comes with two native PCIe 5.1 connectors, which allows to even hook up natively to RTX 5090. That is perfect for any overclocking system or high-end workstations. I'm also currently running this PSU, and so far I'm really satisfied with its quality and performance. The cables are very flexible, there are also cable comms included, and in addition also a 90-degree ATX 24-pin adapter, which also functions as a PSU tester at the same time. The fan is semi-passive, and even at a high load it is still very quiet. Find all information about this PSU in the link in the description. In the first moment you might think, why would they even waste time on making an RTX 5080 water block? And I can tell you, just from a technical perspective, it is much more challenging to cool a 5080 than it is to cool a 5090. That mainly comes down to power density and die size. So the 5090 die size is rather large. We're talking about 750 square millimeters and a TDP of typically max 600 watts, which typically results in about 0.8 watts per square millimeter. Now, the 5080 has a much smaller die, but not that much smaller power consumption. For example, this one can do up to 450 watts. And if you do the math, this would be 1.2 watts per square millimeter. So that's an increase of almost 50%. So almost 50% more power density on the 5080 than a 5090, which makes cooling a 5080 actually more challenging. And then we thought making a water block for this actually makes sense. That's why we created this beast, which is absolutely insane when it comes to cooling and also the features. But of course we will first test the card in the stock condition. However, this card is not fully stock condition, it is a stock cooler, but during all the development phase we also did some work on the card. We had to disassemble it several times, so the thermal paste and also the thermal pads are not stock anymore on this specific sample, so just for transparency. And I've been running Thermark for about 10 minutes now, and the GPU temperature is no longer changing. We see about 71 degrees Celsius on the GPU, about 66 degrees Celsius on the memory, and you can see it's drawing the typically expected about 350 to 360 watts in Thermark. And now we will look at our water block. And I think before we touch it, we first go down into the assembly, and then we will take a look at how this thing is assembled. Every block is individually tested. In this case, because it's a glass version, it is tested at 1 bar pressure, and you can also see that it's not long ago. You probably can't even imagine how painful it is to achieve this kind of surface finish, like on this level, very even, like no flaws, anything on the backplate. I mean, you're looking at this and you're like, okay, that's just a black backplate, and I agree, but I can tell you the way of getting there, it was painful. I think I talked about this in the past already, but the most challenging aspect about this block was making the real glass window happen. We already tried to make this happen with the 5090 water block, but it was not reliable enough back then. We completely had to redesign how the block is internally structured, also about the O-ring, about the glass itself. We changed the glass type, the thickness. So we ended up using 6.5mm thick borosilicate glass. So it's very thick, very stable, and also chemically stable. So not only mechanically, but also especially chemically, which is something that is super helpful for not only cleaning, but also how it looks like. Real glass like this one just reflects the light differently. From my personal aspect, it just gives it an even higher quality look. It's more resistant towards scratching, also if you clean it. It's not really likely that some of the residues will stick to the backside of the glass like you sometimes have with acrylic. And also, for example, we had a case where we had a 5090 water block made with an acrylic glass window, and a customer cleaned it with alcohol. Some of the alcohol reached down through the side to the side of the acrylic, and then the acrylic window eventually cracked because it was attacked by the alcohol. That is something that just can happen with acrylic because it's not that chemically resistant versus especially different types of alcohol. So that is something that's completely different with a glass window, but it's just so much more effort. So we're buying those huge sheets from Schott, the German glass vendor. Then we're processing them, we're water jet cutting, we have to first grind all the edges, then we have to polish all the edges, then you have to check all the glass if there is anything, small cracks or whatever. It's a lot of effort. And we right now only ended up making 120 pieces, it's very small volume production, but we just wanted to make this block happen, just also from my personal perspective, because I wanted to have a block that is like the highest quality you could achieve from both like a visual perspective and also mechanically. It's super challenging, but yeah, I'm really happy how this product turned out. And this is one of the glass windows that is used in this 5080 water block. You can see by the shape, it's not just a simple geometry that it's easy to cut and process. First of all, cutting, but then also manually processing this because the edges, this one, like all of them around, are manually then grinded and also polished to make sure that we don't have any cracks, anything that would damage the block further once it's mounted, right? So we have to eliminate all those risks, and also to make sure that there is no tension inside the glass. To detect possible tension inside the glass, we have this interesting toy. So it has a light source on the bottom, then a polarizing filter on top, and then another one like right on top, which you can see I can rotate. And if it's all dark like this, then the polarizing filter is rotated by 90 degrees versus the bottom one. Now we can take the glass window and we put it underneath, and you can not see a lot. And that's exactly how it should look like. So you can only see the edges being a bit light, which is expected because we grinded and polished those edges. So that makes sense. If there was tension inside the material, we would be able to see this by dark or light spots. Because of the polarized light, the refraction of light would be different in tensions inside the material, and that would be visible by looking through the polarizing filter on top. And to show you what this would look like, we can just heat up an edge of the glass a little bit, and then you can easily see what the tension inside glass would look like. And now I just let it cool down for about 10 minutes. It's still maybe like 30 degrees warm, but not really hot anymore. And if we go back now, we can see the white and dark spots. And those white spots, that's tension inside the glass. That's something we would absolutely not want to see. And that's also what we don't see in our material, right? So that's just to show what would happen if you, or how you can detect tension inside the glass. But the areas that we don't heat are absolutely free of tension. Okay, there was a short side quest, but now we can continue with the block itself. It comes pre-assembled, similar as our 5090 block, also with our Oracle PCB inside. So this PCB is basically recreating a 5080 PCB, and in this state, when the cooler gets delivered to your place, you can just put it inside a motherboard if you want to. You can basically use it as a dummy graphics card and already do your tubing, for example, if you want to. For example, if you don't have your 5080 yet, then you can mount this card exactly the way it would be mounted with the original PCB inside. And following the instructions, we first have to remove the backplate and also the I/O shield. We also use the included PCB, which we call Oracle PCB, as a short guide. Like if you're experienced in water cooling, you don't really need a full guide. You can find all the necessary information directly on here. For example, this is the secondary side placement, which equals the backplate side. So you have markings, for example, for all the pad placements. All of these are 2mm pads and where they would go onto the backplate. And in addition, you can find all the screw informations. So we have 3 different types. We have the first one, which are the circle ones. So they go from 1, 2, 3, 4. That's also the order how you should tighten them. And these, the circle ones, are M2.5 by 4 screws with washers that go directly onto the 5080 PCB. And then afterwards, you have to screw these ones that are marked with the cross. And these are the screws that we just originally removed from the backplate. And also in front for I/O shield, you have all the necessary markings, which screw goes where. Same goes for the front side. You can mainly see 1mm thick pads for the majority, except for 12 volt high power area. That one is still a 2mm pad. And you can find the credits of all the people that were involved of making this block. May it be development, design, packaging design, content, all the machinists and all these. So yeah, that's the Oracle PCB. And that's the inside of the block. And even though you would not see any of this in the assembled state, we paid max effort to achieve exactly this surface finish, which was a huge amount of effort. Also added extra pockets to make it look even better, and also had those, you can see, pockets that are kind of overlapping between the aluminum and the copper. There's a lot of small details, and I'm super happy how this turned out. Card is prepared and cleaned already. I will now start adding Duranout onto the GPU, which is included in the delivery. Then 1mm thermal pads for the VRMs, and then a 2mm pad right here for the 12 volt high power. The thermal pads still have to be manually cut according to these shapes. One of the reasons for that is because there's also thermal putty included in delivery. And if you're deciding to go for putty, then you are left with a big set of thermal pads that are not pre-cut. So those could be universally used for anything else. If they were pre-cut, that would probably not work as well. But I'm deciding to go with pads, so I can just follow the shapes of this and then put it onto the card. Paste and pads are in place, also the small screw with the nut on the bottom holding the I/O shield, and I will now flip it onto the block. And also on the back side, I placed all the thermal pads, and I will now add the backplate. Block is fully assembled and we can finally test it. I also want to note that there is still a very good use for this PCB afterwards, because you can use this to reassemble your original cooler, the air cooler, because it's the same thing as a 5080, just without the GPU and without the memory, but that's not necessary for reassembling the cooler. So you will not lose any screws or anything like that. Everything looks great, nothing is leaking, and the card still works. There's still a bit of air in the loop, but it will just be gone after some time. And also an idle looks okay. We have about 25 degrees Celsius on the GPU and about 36 on the memory. I will now repeat the 10 minutes testing in Firmark. You can also double check the current distribution in the wire view. And we're seeing something between 4.1, 4.2 to just above 5 amps. So that should be all right for a 5080. Test is over. I also switched on the Aqua Computer flow sensor, so we can check values like water temperature is about 27 degrees Celsius. Flow is about 250 liters per hour. We only have the 5080 water block and our micro inline. It's a micro 1851. And now the test result is showing about 49 degrees Celsius on the GPU and about 44 degrees Celsius on the memory. This means that in our setup we are seeing a delta temperature between water and GPU of about 22 degrees Celsius, which is from our testing a very good result for an RTX 5080. We also tested other competition water blocks, but I don't want to do any official comparison for competition products simply because I would be biased and I don't think that's fair, so I will leave that to somebody else. I still hope you enjoyed this video, very deep insight into our 5080 water block that is now available for 550 euros. I know this is extremely expensive, but it's a super extreme product, the highest quality we were ever able to make a product, and super low quantity. Like right now we only made 120 pieces. We will probably still make a bit more, we will see, but yeah. Still super proud on that we achieved making this one. I hope you enjoyed this video. See you next time. Bye bye.